Okay, Batuhan, let's answer your question. I'm going to open up the Pearson in a little bit. Let me close the unnecessary links in here. All right, so let's see. Chapter 3, I will open.
Hocam derse başlamadan önce bir şey sorabilir miyim?
Yes, please.
Bilmediğim için soruyorum hocam, kusura bakmayın da. Recitation derslerimize yoklama alıyor musunuz acaba?
Tabii ki. Zaten recitation diğer dersleri alamadığım için recitation'da alıyorum tabii ki. Ya bu recitation değil aslında da soru recitation'a döndü. Ama burada hem lecture'dan da özet geçiyor. Mesela şimdi birazdan özet yapacağım şeyden. Hani hatırlatma yapacağım. Ama esas hedefimiz dediğin gibi recitation'daki gibi soru çözme saati gibi oldu bu. Kesinlikle yoklama alıyorum, onu söyleyeyim. İsminizi söyler misiniz tekrar? Göremiyorum şu anda. Sertaç, evet. Evet. Okay. Şimdi bir saniye. Let's get to Pearson My Lab. Okay. When it is inactive, it just closes itself. Can you hear my voice well? Like, do you get my voice?
Yes.
Okay, good. That's good.
Teacher, I see now you gave an extra 2 homework. Is it for this month, for next month?
Yeah, it is still actually end of, we will just aim till November 27th, like the same time that other homework ends. If you cannot finish it by then, I think you should finish, because we still have 20 days.
Okay, no problem. I just want to know it.
Yeah, please do that. Okay. Let me open up the assignments here. Which question, Batuhan? Is that Batuhan who answered?
Yes, it was me. Question was,
can you see the screen? Not yet, right? Let me open it.
Not yet, yes.
Okay, let me make it available for you.
16, teacher.
16 or 15?
16.
16, okay.
I did it, but I couldn't simplify it.
Okay, you don't have to. You don't have to simplify it, but I can help you simplify it. Most of the time, I'm not going to ask you to simplify unless the question requires you to. Okay, specifically if they ask you to do. Here, of course, probably in order to give the answer, let us do this, okay? Because we can easily, we have to solve some examples here. So this is a good question to start with. Let's do that. Okay, let me copy this down and write it on OneNote. Okay. All right, so let me see if it's gonna allow me to copy now. Okay, let's get back to our screen, OneNote screen. Let me see this. Okay, it's page 1. This is section 3.3. Let me see whether I have any. Yeah, that's 8, page 8. Okay, by the way, let me give you the information about this new Teams group, which is F20 Math 101 all sections. Here, I also, I registered everybody here, and you can easily get to these written papers here because I'm collaborating. I made it available for you guys. Give it a try if you can see them. If you cannot see them, you can just watch them. On the video, but you can get to them as well. Okay, this is another team that you would see that you registered for. This is for everybody. Everybody is in this team group. Okay. All right. So let's continue here. Okay. So let's get back to 3.3 here. 3.3, as you would remember, that it is we learned the shortcuts for differentiation. So you don't have to work on this limit definition of the derivative anymore, because we learned in section 3.3 the shortcuts. Now we are going to practice that a little here. So this is the question 16. Question 16, yeah. And homework 4. This is homework 4, question 16, yeah? Okay, it says find. You can everybody see my screen? No problem, right? Okay, just a sec, I have to erase this. Oh, yeah, no problem, it was right. I want to erase this. Find y prime given that y is equal to 1 over x squared plus minus 1, x squared plus 5x plus 5. Okay, in section 3.3 we learned about derivative shortcuts, and especially we learned about the product rule, the quotient rule. Probably quotient rule is the maybe hardest. Okay. All right. So here you can see that, okay, a solution. So how would you find this? Actually, the first thing that comes into my mind is writing this as in terms of powers. Okay, so you cannot do that here because you don't know the chain rule. Okay. Actually, after chapter 3.6, let me make an investment here for future chapters. If we had already covered chapter 3.6, I mean, I sent copies actually chain rule. We can also follow that. If okay, the chain rule would make this easier. Okay, this one we would do like this. So I'm gonna solve it in 2 ways. Okay, because I already sent you guys the chain rule lecture. So I'm gonna solve it in 2 ways. Since this is chapter 3.3, you cannot use the chain rule, but just as an investment, I mean, because I'm gonna do it 2 ways. Okay, this is the first way by using the chain rule. Okay, solution one, using chain rule. Okay, using chain rule, chapter 3.6. Okay, since this is 3.3, of course this is not applicable here, but I'm going to do that because we covered 3.6 at least at the first part of it. Okay, the way you are going to do it with the chain rule says, the chain rule is about okay, I'm talking to you about 3.6 a little bit now. When you have composition of 2 functions, it just tells you how to take the derivative of that. Okay, since you see, okay, let me do it like this. So this is my first function. I'm going to call it f of x, and I'm going to call this g of x. All right. So y is equal to actually f times g, right? F times g, whenever, so we have the product of the two. So the first thing we are going to apply is the product rule. So we apply the product rule for the derivatives, okay? The product rule says take the derivative, keep the first one, take the derivative of the second, plus take the derivative of the first. And do you have a question? Do you guys have a question? Okay, I got something. Okay, let me unmute everybody here. I mean, mute everybody, I'm sorry. So that we don't hear noises. All right, so, okay, I'm back to where we left off. So I am going to solve it by using the chain rule first, and then I'm going to solve it in the easy, I mean, without the chain rule. Okay, first we apply the product rule, but I have to find G prime and F prime. So I'm going to take the G prime here. What is G? G of X is, let's see, go up here. G of X is this, the reciprocal of this function, right? So I'm going to take that, the reciprocal of x squared plus 5x plus 5. All right. Okay, so this is it. The chain rule says chain rule is useful when we have composition of two functions. Look at that. We have the inside function and outside function. When you have such a thing, the chain rule says, okay, G prime is equal to, okay, consider there's just nothing in here like U function here. You are going to apply the power rule first. The power rule says take the power in the front, okay, decrease the power by 1, negative 1, negative 1. And then since the base here is a function, okay, so we have to take the derivative of the inside. That's what the chain rule says. Don't forget the inside function. Okay, that's what the chain rule say. Okay, so then G prime at x is going to be equal to negative 1. And this is going to be 1 over x squared plus 5x plus 5 times it with the derivative. Let's take the derivative of this. This is 2 times x, because derivative of a power of x is just take the power in the front, decrease the power by 1, and then plus the derivative of x is 1, 5 times 1, and the derivative of a constant is 0. All right, so I have this expression. So G prime, actually this should be 2. Sorry about that. This is 2, right? Because I take this is negative 2. Let me write that. This makes it negative 2, yeah? So if I put it on under, yeah, if I make the power positive power, so it has to be 2 here. Okay, so I just found that G prime at x is equal to negative 2x plus 5 over what? X squared plus 5x plus 5 to the second power. Okay, this is G prime. Let's find F prime as well. What is F? F is x squared minus 1, raise it to the power negative 1. Okay, so I'm going to take that. So this is my first result. I'm going to use it later. So what is F? F of x is equal to x squared minus 1 to the negative 1. Okay, so again, we are going to use by chain rule. By chain rule, the chain rule says take the derivative at x, take the power to the front, decrease the power by 1, and times it with the derivative of the inside function. This is the inside function. Let me circle it. So this thing is an inside function. Okay, so then this is going to be the derivative, multiply this with, don't forget the inside function, and just take the derivative of it and multiply with it. Okay, so f prime at x is going to be equal to negative 1 over, let's write it in the positive power, to raise it to the second power here in the denominator, and the derivative of this thing is, by power rule, this is 2x and derivative of a constant is 0. Okay, so what's the final answer here? Negative 2x over x squared minus 1 raise it to the second power. So I found this too. I'm not done yet. I just found the derivatives of these guys by using the chain rule, each one of the f and g. But let's get back to the question. Okay, our original function is the product of the two. Look, let's put it in blue color. So our original function y is the product of the two. And so we have to apply the product rule. Okay, now I'm going to apply my findings in the product rule. All right, so I go down. Okay, I have g prime here. I would need that. Okay, and I need the f prime x. Okay, let me copy g prime down here so that I can see them both here. G prime at x was, what was it? Let's go up here. 2x plus 5 and the denominator square of that. Okay, negative 2, just a sec. Two x plus 5, and the denominator is going to be x squared plus 5x plus 5 to the second power. All right, so this is our g prime and this is our f prime. So the derivative of the original function, which did we give it a name? Let me see. We didn't give a name. Let's give it a name as h of x. So let's say this is, I'm going to write it capital X. Okay. Okay, so this capital X, the derivative of capital X is equal to, by the product rule. Okay. All right, so I'm going to write it here. So h prime at x is equal to, okay, f times g prime plus f primes times g, yeah? Okay, what is f? F is x squared minus 1 raise it to the negative power. And what is g prime? G prime is negative 2x, negative 5. I put the negative inside. Okay, over x squared plus 5x plus 5x plus 5. Okay, plus, what is f prime? Let's move to the right, towards right. Okay, plus we said, and then negative 2x over x squared minus 1 to the second power times g. G is, if you like, this is, you can write it if you like this. I'm going to change the other one too. X squared, doesn't matter really. 5x plus 5. Okay, just one sec. I have to move this away. All right. Okay, just
Teacher,
go. Yeah, go ahead.
I did it, but I couldn't simplify, as I said.
Very good. So you don't have to, but in MyLab probably it's going to tell you to do that, right?
Yes,
That's
yes.
the problem. That's the problem. So let's try to simplify it. I just want to make sure I'm missing 2 here, right? Right, I'm missing 2 here because this is G prime. Yeah. Okay, let's go down here. H prime at x is equal to, let's try to simplify as much as we can. Okay, I have 1 over x squared minus 1 here and square here. So what I'm going to do is I'm going to write x squared minus 1 times negative 2x minus 5 on top. Okay, the denominator is now x squared minus 1 squared. Okay, and then times x squared plus 5x plus 5 to the second power plus, I'm trying to equate the denominators. In order to equate, I need one more of these. So negative 2x, x squared plus 5x plus 5 on top, all over the same thing. Okay, now I have the same denominator now. All right, square of that. Okay, once I get the same denominators, I can write just single denominator. Okay, I'm gonna say this is equal to the same denominator. I'm gonna just write d here. D is the denominator this, or maybe I shouldn't do that. So you can get confused. Okay, I'm gonna write that. The denominator is common denominator is x squared minus 1 to the second power, x squared plus 5. Let me see my microphone. Where's my microphone? Okay, is this better now?
Yes.
Or is it the same? Okay.
No, it's okay.
Okay, so we distribute this over. Let's distribute this over negative 2x cubed. So I'm going to distribute this over here. This, and then this, and then this, and then this. I'm going to distribute this over, okay? So let's continue. Negative 2x cubed, negative 5x squared here, plus 2x plus 5. And then plus, and let's distribute this over here, negative 2x cubed here, negative what, negative 10x squared here, and then negative 10x here, okay? So I got that all. Now, are there any simplifications? So this is the same as this, so I'm gonna add them up. And I have, let's write the answer here. Okay. I'm going to go down a little. Maybe I should erase this. Okay. So the denominator is the same. I just write the denominator. I don't want to rewrite that again. Denominator, the same denominator here. And on top, I have negative x cubed. And then this I can combine with this, negative 15 x squared. This I can combine with this. Okay. Okay, for some reason. Okay, negative 8x. And then what is left? 5 is left. Okay, so are there any simplifications? Can you use anything that we can? No, that's also it. So if you write this like that, MyLab should accept it. If it doesn't accept, you write your handwritten result, right? I think for me, this is enough, even without simplifying, it's enough, okay? This is enough, or the one that we did at the beginning, like above, is enough. Like writing it like this is enough for me. So if you write it in your, correctly write it in your handwritten one, even if your MyLab answer is wrong because you weren't able to simplify it the way they want you to do, you're fine.
Teacher, can we solve it with quotient formula?
What formula?
Quotient. I couldn't spell it. Hani şu bölme var ya türevdeki.
Quotient formula. Yeah, we can do that too. Let me do that way too.
Hayır, hocam yorulmayın. Ben sadece sordum.
Yeah, of course. I mean, I was gonna do two ways. The first way was chain rule. This is method 1, solution 1. And solution 2 is just the old way, which is, I mean, the the quotient formula. You can do it with quotient formula as well. Okay? For quotient formula, you are going to, if you want, we can do it. You would just say the derivative of this is 0 times this minus this one, and the derivative of the product all over square of that. And it's going to give you the answer. That's right. Do you want me to do it? If not, then if you want me to, I'm gonna do it. If not, then I'm gonna skip that.
Yok yok, benim için gerek yok. Teşekkür ederim.
Anybody needs it? We can do it because it's a practice. We can do that. Anybody wants that? No. All right. So we can do the quotient too, which is going to turn out to be you are going to need to use the product rule here as well, because the derivative of the denominator is the product of the two, right? Derivative of the product of the two. All right. So let's move on. If you don't have any questions. Okay, I chose. Okay, let's continue here. What I'm gonna do is just a sec. All right, I'm gonna make this a little bit bigger. Not that. Sorry. Not this one. I'm sorry. I was looking for this, and I. Okay. All right. So we move on. Okay, here's there's power rule, blah blah. But let's continue with the examples here. Okay, you can ask me some. Okay, you can choose any one of these for me to solve. Actually, any of these questions you can just choose and I can solve it for you. 27 is similar to the one that we did. Just let me know which one you want me to solve here.
Hocam,
23. Go ahead. Yeah.
Yesterday, your video was about you say some part of the question is u, and write derivative of u.
You mean chain rule?
Yes. No.
Can you write it and show me maybe in the screen, or I don't know what you're talking about. Which chapter, which section do you want? Are you talking about?
Ben bulacağım, döneceğim hocam.
Tamam. In the meantime, I want to solve question here. I want to solve question 50 here. Okay, I want to solve that. Look at the question 50 here. It's a nice question. It says, find all points x, y on the graph f of x is equal to x squared with tangent lines passing through the point 3, 8. Okay. Okay. So we have the graph of x squared. Okay. And so they want us to find all. Okay. Find all, look at the picture. Okay, let me make it a little bit bigger so that you understand question better. Okay, look at this question now. Here we have a curve y is equal to x squared, and we have xy point where we have the tangent line passing through. But this tangent line has another point on it, which is 3 to 8. All right, so the question says, find all points xy such that at those points we are going to have tangent line, and this tangent line is going to go through this point 3, 8. Okay, is that clear to you? Okay, this is a little bit interesting question. Okay, let me do this for you. If you understood though, I can repeat again. So here's a y is equal to x squared. Here's an xy, and we don't know what this xy is, but we know if you draw a tangent line through it, okay, then the tangent line that you draw is gonna certainly go through 3, 8. Okay, so they are asking you to find all such xy points. All right. So first of all, derivative means derivative of this function at this point means it is the slope of this line. Okay, And how can you find the slope of this line? The slope of this line between these 2 points is, just use this point and this point, distance between 2 points, I mean not distance, slope using these 2 points is 8 minus y over 3 minus x. That's the slope. And this value is going to be equal to the derivative of this function at x, right? From there, we are going to solve it and try to get what we want, okay? That's the idea. Okay, let me, if it is clear, I'm going to go and solve it for you. All right, this is a nice question, actually. This is question 50 in our book. Okay, this is, I'm gonna copy paste. I solved some other problems in my previous section. So if you watch other sections, recorded classes as well, it's going to be useful for you, okay? Just look at the examples we are solving. So it's going to be good, very useful for you. I'm going to put them on YouTube. Otherwise, you cannot see them. The reason is you're not in another section to see it. But I'm going to put them in YouTube. Okay. So let's start working on this question. Nice question. This is the question 50. Yeah, question 50. All right. So we have a curve, which is, we have a graph of x squared here, and then okay, and then there's a point xy here. We don't know what this point, and then we draw a tangent line to it. To this graph, it passing through this point, and we know what we know is this. This tangent line is passing through this point. I couldn't write. Passing through this 3 to 8. We know that. But we don't know what this point is. What they are saying is, find this point. Such points could be more than one. Okay, that's going to happen. First of all, we know slope is m. Slope at xy. Let's call this, okay, slope q, point q, okay? Okay, slope at the points q, x, y. We don't know that point, but we are going to find them. Okay, what is this? It is actually, by definition, it's the derivative at x. Okay? So, but what is this function? The function is x squared. Take the derivative, it is 2x. Okay? So this is 2x. And how can I write the slope at q? I can write the slope at q by using these 2 points. Okay? M, let me write it down here. Okay. On the other hand, I can write the slope m between 2 points as 8 minus y, okay, 3 minus x. Okay. But I want to get your attention to this. Look, I'm going to write it in red. Okay. Can you tell me what is y in terms of x? Do you know what this is in terms of x? Can anyone tell me? What is y in terms of x? Can anyone tell? Are you with me or not?
Yes, you are with you.
You are with me, and can anyone make a good guess? What is this y in terms of x? Can we express it in terms of x?
X squared.
That's right, because it's on the curve. So y is equal to x squared here. So actually this q, instead of this y, can I write x squared?
Yes.
Okay, so this is 8 minus x squared over 7 minus x, yeah? But what is this equal to? This is equal to this, which is 2x, yeah? Because it's the derivative. Derivative is the slope. Now, can I solve? Okay, I got an equation. Look, I'm going to circle it in blue. So I have such an equation. If I solve this for x, okay, equation in x. If I solve this, let me put a star here, okay? Solve star for x. Solve star for x. So I'm going to solve it for x. If I solve it for x, then I'm going to be able to find such q. Yeah? Because that's the same x. Okay? So let's solve it for x. So this is 8 minus x squared over 7 minus x is equal to 2x. Okay, 2x over 1. So I am going to do the cross multiplication, right? I'm going to multiply this with this, and I'm going to multiply this with this and equate to each other. So this is going to tell me that 8 minus x squared is equal to 2x times 7 minus x. Yeah? And then from here, 8 minus x squared is equal to 14x minus 2x squared. Okay? Are you okay? Are you good so far? Or if you feel like you are lost, let me know. If you feel like you are lost, let me know and I can explain. Okay, then I'm going to solve for x. So this is, I'm going to move this to this side. So it's going to become x squared. And I'm going to move 8 to the right hand side. I mean, actually, I'm going to gather them on one side. Minus 14x plus 8. I move these guys to the left. And this is equal to 0. Okay, let me clear this up because it doesn't look nice.
Hocam bir şey diyebilir miyim?
Sure.
Bir noktası bilinen doğru denklemiyle karşı taraftaki parabolün denklemini de eşitlesek aynı sonucu bulmaz mıyız?
Say it again.
Şimdi 3,8'i biliyoruz ya, oradan o doğrunun denklemini çıkarırız eğimi bildiğimiz için.
Eğimi bilmiyoruz ki. Eğimin ne olduğunu
Bulduk ya
bilmiyoruz.
hocam.
2x biliyoruz sadece. 2x diye biliyoruz.
Tamam.
We only know we don't know the slope yet. The slope is just 2x at arbitrary point x. It's not a number. It's just a 2x and it changes as x changes. So that's why we need to solve this equation to get that. Okay. Okay, so how would you solve it? 4 times 2 is 8. We are not going to be able to get that. So let's solve it. X is equal to minus b minus plus square root of b squared minus 4ac all over 2a. Let's use this, okay? Okay, otherwise it's not, maybe it's not going to happen easily. We won't be able to find it easily. Just a sec. Okay, so here, what is our b? B is negative 14, so it is 14. Minus plus 14 squared. What is it? 196? Minus 4a, a is 1. Minus 4. All over 2a, a is 1. Okay, so the x that we found.
Professor, you forgot
Yeah.
C in square root.
Yeah, that's right, I'm sorry. 4ac, right, yeah. A is 1, C, okay, 8, 32 then, yeah. Thanks for correction. It just erased it all. Okay, for AC, C is 8, 32. Okay, and then X is going to be, okay, what is that? Okay, this is 4, 6, yeah, 164, isn't it? Okay, square root of this. Can I take out 4? Yes, I can. It is 2 square root of 41. Okay, so I got that. So this is 7 minus plus square root of 41. Okay, this is my x. There are 2 of them. Minus plus. Okay, I have 2 of that. Let me rewrite this because it doesn't look nice. It could be. Let me erase this and write it nicer because when you're studying, you may not really clearly understand what I'm writing here. X is equal to 7 minus plus square root of 41. Okay, so there are 2 x's we found. Okay, but which one is going to be okay? what is this approximately? Let's make a guess. Square root of 41 is approximately what? Square root of 41 is bigger than 6, right? And less than 7. Okay, let's do it like this because we want to just see the value approximately. Okay, this is definitely less than 7, bigger than 6. Okay, so this is telling us that x is between, what is that? So x is between, okay. Let's do the plus. Okay, if we add 7 to it, 13 less than 7 plus square root of 1 less than 14. Okay, this is 1x, and there's another x. All right. Just give me 1 sec. I have a phone call. I'll be back in a little bit. Okay, just give me 1 minute. Okay, I'm back with you guys.
Hocam bir şey sorabilir miyim?
Yeah, go ahead.
Hocam orada 3 yerine 7 yazmışız. Ondan çıkmıyor olabilir. Yukarıda
Hangisi?
eğimi bulurken.
Bir dakika bakalım. Daha çıkayım mı yukarı?
Yukarıda hocam. M yazdık ya eğimi bulurken.
Ha, okey. 7 nereden çıkmış orada acaba, değil mi? Evet. Evet, haklısınız. Nereden çıkmış o bilmiyorum. Okay, there's a mistake here, right? Why did I write 3 here, 7 here? Okay, let's get down to it. Okay, 3. So this is, we are going to correct it. Okay, so is this? I don't know how come we end up with 7 here. 6x. 6x here. Okay, there's a correction. And then now it's going to be okay, I think. Let's erase that. Erase it all. We don't need this anymore. Okay. These are all not right then. Yeah, who was talking? Who commented on this? What's the name? What's your name? Can you hear me?
Yes.
Evet. What's your name?
Batu.
Batu?
Evet.
Ha, Batuhan mı?
Yok hocam sadece Batu.
Okay. Thank you, Batu. Let's see. Okay, we are back here. So this is gonna be negative 6x here. negative 6x, and 8. So this is going to be negative 4, negative 2, and it's easy now. Okay, so we have two values. X minus 4 times x minus 2 is going to be equal to 0. From here, x is equal to 4, x is equal to okay. All right, from here I have x is equal to 4. X is equal to 4, x is equal to 2. Now this is much better because, see, if we get back to the question, where is the question? Pearson. Okay, so so you will see that one of the tangents is 2, and the other tangent is passing through passing through 4, and it's gonna still go through the 3, 8. Okay, so there are 2 points we found. Find all points. So we found both of them, but these are the x values, so we have to convert it. I mean, we have to write it in x and y terms. So let's see. Let's even write the equations, okay, just to see it. All right. So let me call them point S. Whenever x is 2, y is 4, and okay, R. This is the other point on the line, on the curve, I'm sorry, that we are going to have a tangent. So this is 4 to 16. And let's write the equation. And let me write the equations of that. They don't ask about it, but we can just write it to show you guys that it passes through that point. Y minus 4, what is the slope? It is 2 times 2 is 4, x minus 2. This is the first tangent line, and the second tangent line, okay, y minus 16 is equal to 4 times 4 is 6, 2x, right? 8 times, the slope is 2x. So at x is 8, the slope is 8, x minus 4. Let's see whether this passes through 3, 8. How would you check? Okay, so let's check that it's gonna go through 3, 8. So let's plug in. check that tangent lines passes through 3, 8. 0.38, yeah? How would you? For y, you're going to plug in 8, and for x, you're going to plug in 3 and see whether it works or not. So 8 minus 4, is it equal to 4 times 3 minus 2? Yes, it checks. This is 4, this is 4. That's true. Let's check this too. Okay, let's go down a little. Okay. 8 minus 16, is it equal to 8 times x is 3, right? Okay, this is negative 8, this is negative 1, negative 8, this checks too. So we are done. We just checked our work. Okay, is this clear now? Do you want me to explain again this example? Anybody needs me to explain? Okay.
It was clear.
What's that?
It's clear.
Okay, perfect. All right, let's move on. Okay, time is up actually, but I want you to take a look at these questions, and if you want me to, I can solve it. Just give me the number. Okay, let me make it a little bit smaller so that you guys can see it, the numbers at least. and we can start solving one. If you don't want me to solve, then we just skip to the next question, next chapter. We will still continue taking derivatives there as well. Okay, take a look, think about it during the break, and let me know. You can write in the chat. We can solve some problems from here. Otherwise, we are going to move to the next chapter. Next chapter's questions, okay? Okay, so I'm going to leave it like that. Okay, let's meet at 2:05. 2:05. Okay, let me write this here. Let's meet at 2:05, the latest. Meet at 2:05. Okay. Okay, by the way, just a sec. We started at 1, right? Okay, everything is fine. All right. Okay, I'm back here. Let's see. Yeah. Any questions here? If you don't have any questions, I'm going to jump to the next section. I saw those other problems from here in my morning session. You can take a look at them. We saw like 4 questions here. So you should definitely take a look at them, okay? If you don't have any questions, let me check. Okay, thanks, Ahmed. Yeah, no questions from you. So I am going to skip to the next section. So in the next section, let's see. In the next section, yeah, derivative as a rate of change. If you remember, when we were covering chapter 2, I told you that later on we are going to define derivative, and we are going to have this this limit expression. We are going to call it the derivative at x0 or at x at a certain point x, or x0, doesn't matter. And then it is going to be instantaneous speed. I told you about that, right? So that's that's where we are right now. Instantaneous. This is another interpretation of this formula, as you would recall. And in my lecture, I gave examples on that. And here you can see the velocity, instantaneous velocity. Velocity, if s is equal to f of t, is the distance function, then if you take the derivative of the distance function, you get the velocity function. And velocity function has a direction. And you might be remembering average velocity here, displacement over travel time. If you take the limit of this, you get the instantaneous velocity, which I told you before. And here you should look at these 2 graphs. They are important. When a function is increasing, the tangent lines have positive slope. That's the same as the derivative is positive, right? So this is the distance function's graph. So time and s is the distance function, and the derivative is the velocity. So the velocity is positive, and the distance is increasing. Okay, and whenever a function has a graph that is decreasing, then tangent lines will have negative slopes. Therefore, the derivative is going to be negative. In other words, the velocity is going to be negative. That would mean that the object changed direction, because when the velocity is negative, it just changes the direction. Okay, it doesn't mean that speed is going to be negative. Speed is never ever negative, right? Speed is just the absolute value of the velocity. It is the it is either speed is either 0 or positive. So it is the absolute value of the velocity, you will see. So this is just a review. And I talked about this graph in my lecture. I recommend you to take a look. And I did these problems in my lecture. Let's continue. So let me see. I did a nice question at the end. I did this question in the morning. You can take a look at the morning session as well. I mean, you should definitely look at this example. I can do another example for you guys. Okay. For example, I want to do this example. Let's see. Okay, what does it say? Okay, number 16. We can do number 16. A particle P moves on the number line shown in part A of the accompanying figure. Part B shows the position of the P as a function of time. Can you hear my voice? Can you get my voice?
Yes.
Okay,
Yes.
perfect. Thank you. Thank you for confirming. Let me get some tea. Okay, my voice is better as I drink tea. But it has to be herbal tea, right? Regular tea doesn't help. Okay.
Yeah.
Okay, so I'm going to make this a little bit bigger for you to see. This is a nice question. I did a similar question in the morning, question 15. So you should, if you don't understand this, definitely watch that as well. So there's a number line and the point particle is moving towards right or towards left, depending on its velocity. If the velocity is positive, it's going to move towards right. If the velocity is negative, it's going to move in the opposite direction. Okay. All right. So P is a function of t, shows the position of the function, position of the object that's traveling. The question is, when is P moving to the left? Okay. So what they are saying is, when does the object have negative velocity? Because whenever it has negative velocity, then it is going to be it's going to move towards left. Okay. So how would I know? But here you won't be able to see the velocity. In the previous question, actually, it was the graph velocity versus time. So it would be easy for if it was the velocity versus time graph. But here it is the S position function graph. So it is different. So in this case, what we should look for is, we know the velocity is the derivative of S. So we should look at the slopes of this graph. If we look at the parts where the slope is negative. So let's start analyzing it. So here, so slope is going to be negative when the function is decreasing, right? So here it is increasing, here it is constant. Whenever the function is constant, the velocity is 0. The slope is 0 because, and here when the function is increasing, slope is positive. So we don't have a negative velocity yet. But here between 2 and 3, the function is going down. So the slope is negative. All right. So this is when the velocity is negative. So this is when it changes the direction. Okay. At 2, it changes the direction. And then let's continue here. The object stayed at the position -2 for 2 seconds or minutes, whatever the unit is. Okay. And then afterwards, the slope is still negative, so it is moving in the same direction towards left. So when is the P moving to the left? So it's going to move to the left between time 2 and time 6, because it's going to be in the negative direction, right? The velocity is negative, okay? And when is it going to be moving right? It is moving right 0 to 1. It's going to stay where it is at between 1 and 2. Okay, so we don't say, you can either say 0 to 2 or 0 to 1, doesn't matter. And standing still, if they ask standing still separately, so we have to separate that. So 0 to 1, it is moving towards right. 1 to 2, staying still. 2 to 3, it is moving towards left. 3 to 5, it is staying still, standing still. And 5 to 6, it is moving towards left. Okay. And then it says graph the particle's velocity and speed were defined. So we are going to draw the graph of the derivative of that. Okay, 0 to 1, the derivative is, the slope is 2. So we are going to draw 2. Okay, let me draw that by using the graph. So this is 16. Let's open up a new page. Okay, 3.4, maybe page 2. Page 2, 3.4. Okay, question number 16. Okay, 16. Okay. We did the A, so I'm answering the B. Okay. The answer to B is, we are going to draw the graph, or maybe we should write it first. Okay, we should write what they are. So, okay, 0 to 1. Okay, 0 to 1. What is that? Let's get back to where we left off. 0 to 1, S is increasing, their M is positive. Okay, maybe I should draw this and show you there. It is much better. Just give me a couple of minutes. Okay, it is much better that way. You understand more. Okay, so go up this, go down towards right, and this. This is 1, this is 2, this is 3, and this is 5, and this is 6, okay. And this is 2, and this is -2, this is -4. Okay, so let's draw the graph actually. Okay, I am gonna draw the graph. It is, so here's the graph. Okay, so I have 1 here, I have 2 here, I have 3, I have 4, I have 5, I have 6. Okay, so I have 2 here, I have -2 here and -4 here. Okay, this is S, distance function, this is time t. So this is going up and it's gonna standing still till, let's say till 2. And then it's gonna go to, go down to here, passing through 3 here. And then it's gonna stay still till 5, I guess. Let's see, I think I drew this wrong. Let me go back to it. 3 to 5, 3 to 5, 3 to 5, 3 to 5, it's standing still. So I have to erase this. Okay, erase this too. Okay, let's draw the 3 to 5. It's standing still. And then from here to here, you have that. And then after, okay, after 5, it is going down till 4. Okay, it is this. All right. Okay, so I'm interested in S prime. So I'm gonna just look at the function being increasing or decreasing. Let's get the color. This is increasing here. This is constant. Function is constant. This is decreasing all over here, decreasing, decreasing. Okay, constant, not changing, standing still. And this is decreasing as well, decreasing here. Whenever it's decreasing, slope is negative. Whenever constant, slope is 0. Whenever decreasing, slope is negative, slope is 0. And what is this? Slope is positive. Okay, so I'm going to draw the graph accordingly. So maybe I should do the graph on here. Okay, I'm going to use the green color. Okay, the green one is about the velocity. Okay, so between 0 and 1, what is the slope? It's 2 over 1, which is 2. So the green one is the slope. Okay, and then these parts. Okay, so these are corners. So I'm gonna leave it like this. Okay, here it is 0. Okay, between 1 and 2, it is 0. Slope is 0. Okay, here, what is the slope? So this is, what's the difference? 4 divided by 1, it is 4, -4. So here it is gonna go here. This is the green one. Okay, and then 3 to 5, it is 0 again. Okay, and then 5 to 6, what is the slope? It is just 1 unit, 2 units, it is 2, but it's -2, so it's gonna be this. Okay, the green one is the velocity ds dt. Okay, all right, so probably this corner, maybe I should exclude. I mean, you understand that what I mean here. Okay, let me see, are there anything? Yeah, I want to erase these greens here. Yeah, let's get back to it. This is good. I had the constants. Okay, blue here. I had blue here, right? And then what else? I had this. Okay, and I need the green here. Okay, this is the graph that I need ds dt. Okay, whenever the slope is positive, the slope here, as you see, it's above x-axis, it's positive, slope is 0 here, slope is negative because function is decreasing, and slope is negative because function is decreasing, and it is 0 here because slope is 0, because the function is constant. Any questions? Do you have any questions? No? Can you follow me? I mean, is it okay, or can you not follow me?
It's clear, Professor.
Yeah,
Okay, glad to
right.
hear. Okay, let's move to the next page, next section, which is chain rule, I think. 3.5, or which one? 3.5, 3.6 is chain rule. Let's see, 3.5 is what? Trigonometric functions, derivatives of trigonometric functions, okay? So here we have the derivative of sine, and derivative of sine is cosine. This is the proof of it. And derivative of the cosine is negative sine. Here is the proof of it. And and what else? We must have a table somewhere. Okay. Derivative of tangent, secant squared, derivative of secant takes, tangent takes, derivative of cotangent is negative cosecant squared, derivative of cosecant takes is negative cosecant cotangent. Okay? And we are going to solve some problems now. Excuse me. Okay. So I'm going to show you some of them. You can choose whichever you like, and we can solve it here. Just let me know the number. Let's solve it. If you cannot choose, I will choose. Just write the numbers in the chat. Okay, did you write? I'm waiting for your 20. Okay. Okay, Batuan. I'm going to start with 20, but you can ask more. Okay. Number 20. Okay, so it says find the SDT and negative secant t plus 1. Okay, let's do that. Okay. Okay, I hope I started the recording. Okay, good. Sometimes I forget. Okay. All right, so this is 20. Question 20 from the book. Okay, question 20 here. Okay, so f of t is 1 plus something, just a sec. T squared minus secant t plus 1. T squared minus secant t. T squared minus secant t plus 1. Okay, so we want to find f prime, right? Are there any questions in here? Let's see. Find the SDT. That's, yeah. I call it f, but you can call it anything you like, no problem. Okay, so the derivative of the power rule is 2t. I mean, this t squared, the derivative is 2t, and the derivative of secant is secant t tangent t. Okay, the derivative of that. And the derivative of 1 is 0. Okay, that's it. So that's the final answer. Okay. Okay, choose another one.
Bu mu hocam answer?
Huh? That's
Bu
the
mu
answer.
answer?
Evet, evet.
Daha tanjanttan devam etmeyecek miyiz daha?
Nasıl?
Yani sekantı açtıktan sonra açılmış halinin türevini
Yo.
almayacak.
Hayır.
Ha, tamam o zaman.
Hayır, bu kadar.
Kolaymış.
It's not chain rule, right? You don't need a chain rule here or anything like that. So let me rewrite this. This doesn't look nice. Let me rewrite that. Any other questions, please? Okay, but 2 says 7. Let's go back to it. Sine x times tangent x. Okay. Okay, this is question 7. I'm going to call it f of t again. Sine t, tangent t. X or t doesn't matter really. Okay. So there are two ways to do this. Okay. Either you can open this up like you can write sine over cosine, and on top you're going to have sine squared t over cosine t and take the derivative accordingly, or you can leave it like this and do it. So I'm going to leave it like this and I'm going to solve it. Okay, f prime, I'm going to use the product rule. So keep the first, take the derivative of the second. What's the derivative of tangent? The derivative of tangent is secant squared t. Plus, what's the derivative of sine? It is cosine t times tangent t. Sorry about that. Okay, tangent t. If I want, I can simplify it. I can simplify sine secant t is 1 over what? 1 over cosine. Here, no, not very much flexibility here. Sine t, secant squared t, just leave it as it is. But here, tangent t is sine over cosine, so cosines are going to cancel, so I have sine t left. Yeah, I can factor out sine t. Okay, I can factor out sine t. I have 1 plus secant squared t. But 1 plus secant squared t is special. Okay, if you remember, it is tangent squared t. Look at that, sine t. Okay, why is that? This is 1 over cosine squared. Okay, just a sec. We must have that. Let's see. Or secant squared t, 1 over cosine squared t. It doesn't give me that. Yeah, this is just it. 1 minus. Okay, it's not that. Okay, just leave it like that. We cannot simplify any further. Okay, just leave it at that. 1 plus tangent squared t is secant squared t, which we don't have it here. Okay, 53, let's do that. Let's get back to 53. Okay, so here, as x goes to 0, let's first, let me make it a bit bigger for you. Okay, 53, let's plug in 0. And if it is undefined, then we will think about fixing it. Secant x is 1 over cosine. Cosine 0 is 1. This is pi over 4. Tangent pi over 4 is what? 1. Tangent 45 is 1. Pi minus pi times 1 is pi. Okay, cosine 0 is 1. 1 minus 1 is 0. There is pi here. Secant pi. What is secant pi? 1 over cosine. Cosine pi, negative 1. So we are good to go. Okay. Everything looks okay. We just plug it in. Okay, we just plug this in. Let's do it again. Okay. Secant 0 is what? 1 over cosine 0. Cosine 0 is 1. So this makes pi over 4. Tangent pi over 4 is 1. Tangent 45 is 1. Pi times 1 is pi. Okay, cosine 0 is 1. 1 minus 1 is 0. We have pi here. The answer is secant pi. Secant pi is 1 over cosine pi. Cosine pi is negative 1. The answer is negative 1. Is this clear? Or do you want me to write it down? Shahsinem, is this clear?
Yes, teacher, thank you. It's clear.
Okay. Salahattin, I'm going to do number 50 for you. number 50. Let's get this 50. Cosecant x is 1 over secant x. Secant pi, okay, 1 over, I mean, 1 over sine x, I'm sorry. 1 over sine x. Okay, 1 over sine. Sine pi over 6 is negative pi over 6. What is, let's go back to our here, okay? I'm going to just take notes. I'm going to erase that later on. Okay, and sine negative pi over 6. Pi over 6 is 180 divided by 6 is 30. Sine is an odd function, so it is negative sine pi over 6. Okay, this is sine 30 degrees. Sine 30 degrees is 1 over 2. But there's minus here, so it is negative 1 over 2. Okay, let's get back to the question. Okay, where are we? Negative 1 over 2. Okay, I was doing sine, right? We should take the reciprocal of that. Cosine pi. Okay, let me do that here. Okay, cosine. I'm going to do that part. Cosine pi cosecant negative pi over 6. Yeah. What is this? Let's check it. Cosine pi cosecant negative pi over 6. Okay, so cosecant is 1 over sine. So this part, 1 over sine of this is negative 2. Okay, cosine negative 2 pi is the same as cosine 2 pi because it's an even function. Okay, cosine 2 pi is 1. Okay, we did until here. Okay, this is 1. And then 1 plus 1 is 2. Square root of 2 is the answer here. Okay, is this clear?
Yeah, Professor, thank you.
Okay, so if you want me to do more, we can, but we can skip to the next section, which is, we have 14 minutes. We can do some chain rule if you like. You can gather your questions and we can do, I mean, we can solve it some other time as well. Let's see. Yeah, just think about your questions and we can solve it some other time. Let's do some, in 14 minutes, let's do some chain rule. Okay, in chain rule. Chain rule is good, as I told you at the beginning, we gave an example. It is good when you have composition of functions and you have to, you are asked to differentiate it, okay? Let's open up the questions. There are some rules. Let's remember some rules maybe before we start. We have the general, we have the power rule, we have the general power rule, I guess, here somewhere. Power chain rule we have. And what else we have here? Yeah, power chain rule. And then anything to remind you here. Outside, inside rule. Inside function, outside function. And sometimes we have to repeat chain rule over and over, okay? Because of composition of, if you have composition of more than 2 or 3 functions, then you have to repeat it over and over. So that's what it's saying. And yeah, that's the chain rule we have, right? Okay, that's the proof of it. Let's get back to the questions. Okay, you can tell me which numbers you want me to solve, and we can solve it. Okay, just choose and write it in the chat, and then we go from there. You have to hurry because time is passing very quickly. Just choose some number, just tell me some numbers. You can speak up as well if you want.
Teacher, I wrote it, but
I didn't see it. I can't see it though. No, I don't see it somehow. Salahattin wrote 50 and that's all I have right now here. Did you send it really? Batuhan?
yes, 32.
Which one?
I thought
33,
33.
Professor.
33.
Maybe I have to. Why doesn't it show me? Okay, let me close the chat and open up again. Now I see it. Interesting. Okay, Batuhan, thank you. Let's get to the number 33. Okay, we have square root of 7 plus x secant x. This is, let's see. Let me erase this part because otherwise you can get confused here. Or what is this? Just a sec. Yeah, this part is does not belong to here. So we did this for another question, so I skipped that. I erased that. Okay. Because you can access these written parts, so I don't want you to get confused. Okay, we are done with that. And let's get back to here. Okay, so this is 3.6 and this is page 2. Actually, I prepared some questions here too for you guys. Like in page 1 here, I have a couple of questions which I wanna, where is this? I hid them somewhere here. It's there here. Okay, these are the ones that I actually chose from you guys. Okay, let's do yours first. And then if we have time, we can do them later, okay? Okay, let's write it down. Square root of 7 plus x secant x. Square root of 7. Square root of 7 plus x secant x. Okay, this is f of x. And this is the problem 33. Okay, problem 33 from the book. Okay, so solution, find f prime using chain rule, of course. Solution, you don't have any other way, okay? You cannot do any other way. Okay, first of all, I want you to write this in power form. That's the best, it's the best way to start it. Raise it to the power 1/2, okay? Write in power form. Write in power form. Power format, whatever. Okay, and then next, excuse me, we have the inside function. This is the inside function. And this is the outside function, this one. Square root, outside function. Okay, so the rule goes as follows. You take the derivative as follows. Take the derivative of the outside function. The outside function is power rule. Take the power to the front. Decrease the power by 1, -1/2. Write the base, which is 7 plus x secant x. And then multiply this with the derivative of the inside function. That's the rule, the derivative of the inside. 7 plus x secant x. Yeah? That's the inside outside rule. Yeah? This is the chain rule, okay? Because it's the f is composite of two functions, inside and outside function, and you take the derivative like that. So 1/2, you can write the power as positive power. All right. And now what's the derivative of this? The derivative of a constant is 0, and the derivative of this product rule. Okay, the derivative of this, keep the first one, derivative of the second is secant tangent, plus take the derivative of x, which is 1, times the second function, which is secant x. Okay, so if you want to rewrite this, you can factor out secant x if you like. You don't have to, but when you're answering in MyLab, you may want to try it. If they don't accept this answer, you sometimes have to rewrite it in different formats so that it accepts it. Okay, this is another way to write it. And that's it. Done. Okay, we have 6 minutes. I can still answer. Do you have any questions about this example? Let me check whether you have more. Okay, if you don't have more, then I can solve the problems that I copied here. This is it. Yeah. Okay. All right, so let's get back to it. Find the derivatives of the following functions by using chain rule. So here's one. Here's another one. This is the second derivative. And I have another one. This you're going to take the second derivative here as well. And these
Teacher,
are other questions. Yeah, go ahead.
I can see your screen, but
You can or cannot?
I can't.
Okay. Who are you?
Batuhan?
Batuhan, can you see can you see it now?
No. I think it's my problem.
Okay, let me
I rejoin,
it.
okay?
Okay.
Ben yapıyorum hocam hala.
Oldu mu?
Geldi hocam, tamam.
Tamam, güzel. Okay. Okay, so I have this, it says, so I have a couple questions, okay, here written. We can start solving some of them. Maybe we can solve this one. Okay, let's solve it. This is actually, you are going to use the, you're going to use the chain rule repeatedly. Look, I have sine x, I have cosine x, and I have 2t minus 5. So there are 3 functions composed here. So I'm going to do the chain rule over and over. Repeated chain rule, okay? So let me copy this into a new page, and then let's do it. Okay. Let me see whether it's gonna let me copy this page. Copy. Maybe it's gonna copy itself. Hopefully, I guess, yeah, it copied itself. So I'm gonna say, this is page 3 here, okay? And then I'm gonna start solving it. Let's see whether it's gonna go down. Yeah, okay, good. So I'm gonna solve it here. Let's move this towards right a little bit so that I have more room in here. Okay, good. Okay, so you're gonna see the chain rule applied repeatedly. So solution Okay. Here, f prime at t is going to be like this. So I have, this is the outside function, and I consider this as inside function, okay? So the derivative of the outside function is cosine. I mean, not t, sorry about that. Okay, cosine. And then I'm going to open up and write the inside function here. Cosine 2t minus 5. Okay, times it with the derivative of the inside function. That's the rule. Okay, that's the rule. Inside outside rule. Cosine. Let's move towards right a little. Okay. Cosine 2t minus 5. Now I'm interested in taking the derivative of this, but you see we have an inside and outside function again. So this time my outside becomes this and my inside becomes this. So I'm going to apply the chain rule once again. Okay, so this is going to be equal to, let's write it in this color, cosine 2t minus 5, this is what we had done before, times the derivative of this is derivative of the outside function. This is the outside function, outside. This is the inside function, inside. Okay, the derivative of the outside is negative sign. Open this up and write the inside function. And then multiply this with the derivative of the inside function, the derivative of the inside function. That's the inside-outside rule. And do we know this? Actually, we know this. This is easy to take the derivative of this up. This is just 2, because the derivative of 2t is 2. The derivative of negative 5 is 0. So this is equal to 2. Now I'm going to write my answer in red. Cosine 2t minus 5 times it, negative sine 2t minus 5, and then times 2. That's the final answer. You don't have to simplify. You cannot simplify it at all. You can rewrite it if you like. Take this negative and 2 out, and you are good to go. I mean, even this is okay if you write it in your solutions. That's it. So let me. Is this clear? Any questions about that? Is this too much? Like, do you not feel like you're ready for this section? Is this too much for you guys? Okay.
Oh, it's clear.
Okay, perfect. Good to hear.
It is clear, Professor.
Wonderful. Good to hear. Okay, so time is up. If you want me to, I can do one more, but if you have to go to other classes, you can leave. Let me take the attendance as well at the same time. I am going to take the attendance here. Yeah, otherwise, if you don't have any other questions, if you don't want me to solve another, you can leave if you like.
Okay, bye, teacher. I have another
Bye-bye.
class.
Yeah, bye-bye. Enjoy your
Bye.
class. Bye.
Thank you.
See you.
Thanks. Bye-bye.
Teacher,
Yes.
I just want to apologize for the reputation lessons attendance. There is a misunderstanding fault by me. I'm very sorry about that. After this time, I'm here in the
Yes,
session.
please. Yeah, please attend.
Sorry again.
No problem. Thank you. Bye-bye.
Hocam bir şey sorabilir miyim?
Tabii ki.
Hocam son çözdüğümüz soruyu bir daha görebilir miyim? Soruyu yazamadım da.
Tabii ki. Tabii ki. Bir saniye.
Ekran görüntüsünü de alayım.
Tabii. Açmaya çalışıyorum şimdi. Şurada. Şu. İlk kısmını da almak istiyor musunuz?
Hocam sadece soruyu alsam, çözümü değil.
Tamam, güzel. Soru şurada. Soru şu.
Tamamdır hocam. Teşekkür ederim.
Hı hı,
Çok sağ olun.
Sağ ol. Hı hı.
Görüşürüz.
Görüşürüz. Sağ ol.